let's go ahead and look at section 2.4 and section 2.5. Let's cover these two sections together. The topic is linear functions and equations of lines. And this is a topic that you've seen before and maybe more than once in previous math courses. And so I want to consolidate the material just a little bit, and so that's the reason that we're going to cover the two sections together. So a linear function just means that there's a constant rate of change or a constant slope. And so what is slope? Well, slope just measures the steepness and the direction of a line. So, if you have a coordinate plane, an x and a y axis, then your line might go in this direction, or it might go in some other direction, or it might go in some other direction. And so slope is a number that describes the particular direction of the line. And so you can calculate the slope using this formula here, y2 minus y1 over x2 minus x1. Right before that, there's the Greek letter delta, which just means change. So change in y over change in x. With the Greek delta, and also in words. And then we're also familiar with the idea of rise over run. Rise is the change in y, run is the change in x. So we have several ways to write the equation of a line. You see point slope form, and you see slope intercept form. Those are the most important. There's also a standard form, which we'll come to a little bit later in these videos. I would like to take just a moment to show you how the point slope form and the slope intercept form come directly from the slope formula. So I'm going to take a moment to do that, and then we'll go on and we'll work through some examples, starting with this graphing that you see down here in example 1. But first things first. So your formula for slope says y2 minus y1 over x2 minus x1. And so when we use this formula, we're given 2 points, and those 2 points are x1 comma y1 and x2 comma y2. And so in order to get the equation of a line, what we want to do is we want to hold this first point fixed. We want to think of it as a particular point on the line. And then this second point can move. It can be anywhere else on the line. And so instead of calling it x2, y2 to make it sound like a particular point, we're going to call it x and y to make it sound like an arbitrary point, or a point that can change, that can move along the line. So what we're going to do is we're going to start with the formula for slope. We have m equals y2 minus y1 over x2 minus x1. And then we're going to replace x2 with x, and we're going to replace y2 with y. And so then that will give us m is equal to y minus y1 over x minus x1. And then we're just going to do a little algebra to this equation. So in particular, let's multiply both sides by this denominator, x minus x1. We will have m times x minus x1 is equal to y minus y1. And of course, that's exactly the formula for point-slope form. So point-slope form comes directly from the formula for slope. Okay, so then let's look at the slope-intercept form. So now, with slope-intercept form, what we're going to do is we're going to replace the particular point x1, y1 that could be anywhere on the line. We're going to replace it with a very special point on the line, which is the y-intercept. So we're going to choose that fixed point so that the x-coordinate is always 0. And then we could still call it 0, y1, but we shouldn't do that. We should give it a special name or a better name to indicate that it's the y value that goes with x equal to 0. And so the convention is to choose the letter B. And so if we just take that special point, 0, b, instead of any old fixed point x1, y1, then we can see the slope-intercept form. So what we're going to do is we're going to replace x1 with 0. And we're going to replace y1 with b. And so then we would have x minus 0 is just x, so we have mx on the left side, and we have y minus b on the right side. And when we add b to both sides, we get mx plus b is equal to y, which of course is the same as y equals mx plus b, the slope-intercept form. So isn't it nice how things all fit together? Okay, we can talk about the standard form a little bit later. For now, what I'd like to do is I'd like to go on and get into example 1. So I'd like to remind you again, a lot of this is review, and so there's a good chance you know how to graph this line. You should pause the video and try it for yourself. And what I've done is I've tried to consolidate ideas in these two sections so that we can move through the material a little bit quicker and still be thorough and complete in the explanation in these videos. So let's go ahead and look at example number 1. We just want to graph a line, and so there are a couple different ways to do this, but probably the quickest way or the easiest way would be to recognize that we have an equation in the form y equals mx plus b, and so we know that the slope is m and the y-intercept is b. And so what we can do is we can start by graphing the y-intercept. And so the value of b in this equation is 3. And so, of course, the x-coordinate that goes with that is 0. That's what it means to be a y-intercept. And so we can plot the point at 0, 3. And then we can use the slope to plot more points. And so the slope is, in this equation, is -2. And remember, that's a rise and a run. That's a numerator and a denominator. So we need to think of this as -2 over 1. And then if we think of it that way, then the -2 says go this much in the y direction, go down 2, right? The negative sign tells us the negative y direction, down, and then go to the right 1. That's the positive horizontal direction, a distance of 1. And so we start from the y-intercept at 0, 3, and we go down to 1, 2, and to the right 1, and there's another point, and down 2 and right 1, and we can keep doing that as far as we like. We could also do up 2 and left 1, right? Up 2 and left 1, and of course that up 2 would be a positive 2, and left 1 would be a negative 1. And isn't that the same slope, -2, whether the negative sign is in the numerator like we started out with or in the denominator? Doesn't matter. So now we have a bunch of points on this line, and now we can take our ruler and draw a nice straight line through these points. And there's the line. A second way that we could graph this line is by making a table of values, and that's what we did back in section 2.1, and I won't do that again now, but it should be familiar, and you might want to look back at, you might want to try to make a table of values, or you might want to look back at your notes for 2.1 and make sure that sounds familiar. Okay, let's go on to example 1b. This time we have the equation 3x minus 4y equals 0. Now, slope-intercept form worked real well for us in the previous example. Could we rewrite this equation into slope-intercept form? We could. So let's do it like that. Let's subtract 3x on both sides of this equation. And of course what we're doing is we're solving for y. So we're going to have -4y equals -3x. And then when we divide by -4, we get y equals 3/4 x. And so does that look like slope-intercept form? I think it does, although you might say, well, where is the b value? Can you tell what b is? B in this problem is 0. And so the y-intercept is at the origin, 0, 0. And we can plot that point. And the slope in this problem is 3/4. And so that means go up 3 in the y direction and go right 4 in the x direction. So we can go up 3 from 0, 0, up 3 and right 4. And we can plot the point at 4, 3. We could also go down 3 and left 4 to get another point if we like. And then we can go ahead and draw our line. Okay, so hopefully that looks pretty good. There are a couple more that I want to show you. These two now are special lines. You'll see why in just a moment. Here we have f of x is equal to 3, and of course, if we think of y equals mx plus b, like we did in the previous problem, well, that's fine, but we just have to be careful. What is the value of m and what is the value of b? Well, can you see that M is 0 and B is 3? So 0 times x plus 3 is the same as 3. And so now we're into the form that we need. So our B value is going to be 3. And so that gives us the point at 0, 3. And our slope is 0, which we can rewrite as 0 over 1, so that we have a rise and a run. And we can go ahead and plot some points. So if we start at the point 0, 3, and then the slope says go up 0 and right 1, then that means we're only going to the right. That means that the line is horizontal. And we could keep going to the right, plotting points. We could go back to the left, plotting points. But ultimately, what we have is this horizontal line. So I can draw that in. And there's f of x is equal to 3. Remember, f of x is the same as y. And so in this special case where we have y equals a constant, then that gives us a horizontal line. And, you know, it doesn't matter what the value of x is. X can be anything, and y is always 3. So now, let's go on to the next one. This time we have x equals 3. This one is a little bit tricky. This one we can't solve for y, right? We can't put it in the form y equals mx plus b. So what are we going to do? Well, we're going to think of we're going to compare x equals 3 with the line that we just graphed, y equals 3. If y equals 3 is a horizontal line, then maybe it makes sense that x equals 3 is a vertical line. And so what this says here, when this says x equals 3, that means x must be 3, and then y can be anything. Y can be 0 or 1 or 2 or 3. And then we can graph this. This line now is vertical. And so here's x equals 3. So if we have x equals a constant, then we have a vertical line. And there was one more thing that we wanted to talk about, and that's the slope. And we already said it. When we had y equals 3, the slope was 0. So that's true for any horizontal line. And then what's the slope of this vertical line? Well, the rise is, let's see here, if we say slope is rise over run, you could pick any 2 points on this vertical line. Let's just pick 3, 0 and 3, 1. Well, how far did we go up? We went up 1, so that's the rise. And the run is the horizontal change, that's 0. And so this is undefined. With the denominator 0, the slope is undefined. And so there's another way that we say that. We say there's no slope, which is not the same as 0 slope. That could be a little confusing. Students sometimes get those two mixed up. 0 slope is a horizontal line. No slope means undefined slope, means we have a vertical line.